let's look at a different method to divide polynomials. This method is called synthetic division. It's faster, but it only works in certain situations. Let me explain. So what we want to do, and here's the method, we want to set up a grid, and this is just some arbitrary cubic polynomial here, ax cubed plus bx squared plus cx plus d, divided by some divisor of the form x minus k. Now, this form is very important for this method. Anyway, if we have something like this, what we do is we set up a grid that looks like this. We put the k, so it's part right here, outside. We draw a vertical bar and then over, leave some room here and also some room below. In line with the k, we put the coefficients of the polynomial. So the coefficients here are a, b, c, and d in descending order without skipping a power. So if this were missing, let's say the b here was 0, we'd have to include that. All right, and then the procedure works as follows. We want to start by bringing down the first term. So it would be the a here. We bring that down. Then we multiply by k, so k times a, and we write that here in the next column above the line. So k times a. And then the next step is to add. So we add in this direction, and we would get some number. I'm not going to fill that in. We would have numbers here. We could add them. And then we repeat the procedure. So we multiply by k, and then add. So we'll have some number here, multiply by k, and then add. The last part here will be the remainder. Okay, let's see this in action. Here's the example from the long division video. We're going to divide 2x cubed minus 5x squared plus x minus 8 by x minus 3. And we can identify all the components in the synthetic division algorithm right here. X minus k is the divisor, x minus 3. Therefore, 3 is the number that we should start with outside. Not negative 3, 3. All right, we'll draw a bar, and now we'll write down all the coefficients. Starting with the largest, going to the constant term. So 2, negative 5, 1, and negative 8. All right. Now we'll follow the procedure. Bring down the 2, multiply. 3 times 2 is 6. Then we add. Negative 5 plus 6 is 1. Multiply. 3 times 1 is 3. Add. 1 plus 3 is 4. Multiply. 3 times 4, 12. Add. Negative 8 plus 12 is 4. And we'll divide that up. So these numbers right here are the coefficients of the quotient. And we could write that down. It's always going to be 1 power less than this, so it's 2x squared plus x plus 4. This term is the remainder, 4 over x minus 3. If you notice, this is the same answer we got via long division. Some things to note here. This method is generally quicker. We can run through multiplying and adding a lot better than we can try to, I guess, essentially factor and then multiply. Long division also takes up a lot more space. We can use the synthetic division algorithm that's really just about 3 lines, no matter what the polynomials look like. Then we just convert back to a polynomial, or recognize that these are coefficients, and write down the remainder term. Now, this remainder term is also very interesting, and we'll talk about that in the future examples as to what else this tells us, this number right here. We'll look forward to that.